Monday. It was a beautiful weekend. I hope you guys have gotten out and really appreciated the show that is going on right now with the leaves. They are freaking amazing everywhere. And yeah, it's the greatest artwork of all time. And so we're very blessed with it. All right. And that is actually chemical compounds. So the chlorophyll is the green color that we always see. And as the chlorophyll breaks down the molecule as the sun is moving far away, the other molecules that are there start coming out. And they're actually really good antioxidants, going with what I just talked about. All right, as I mentioned, once mentioned again, on the worksheet for Wednesday, there is a typo on the bonus question. And it is that I forgot to give you a volume and a temperature. And so that would be the volume you need and the temperature. So just make a note of that. The other thing I wanted to mention, because I have a note to me, is you guys have 2 labs this week. So the one is the gas lab, got gas. And so I sent out an email on Saturday. If you have not looked at that lab, please look at it tonight. There are 6 choices you have. You have to pick 2 of the 6 and do whatever it says. 3 of the 6 choices are a 7-day challenge, which means you have to do it for 7 days. If you decide to do one of them, which I'm hoping you do. My class, we did this actually in the spring, and they had, it was really fun. So if you didn't look at the lab, do look at it, and you would start your 7-day challenge today, and you would just submit it on Monday. I won't mark it wrong, or I won't mark it, sorry, I won't mark it late, as long as it's in by Monday. If it was because of a 7-day challenge, and you also humbly comment, yeah, I'm one of those students who was out enjoying looking at all the leaves and this beautiful weekend and Halloween. And, you know, being humble is actually a virtue. I'm pretty sure it's one of the meek and humble, right? They will inherit the earth. All right. It's one of the Beatitudes. I love that name. So there is another lab this week. And so that's great, because labs, they're 10 points. And so those are good points. So the second lab is hot off the press. It will be there tomorrow morning. So it's going to be lab 6 and lab 6B. So we keep it in the week. It's going to be about solids. I had a make a choice. I had several ideas of labs I could do related to this, but I realized we spend time on liquids. We're spending this week on gases, and solids really need. So we finish out the elementals, which goes back to what we started with the very beginning of the term. I don't know if you remember the video that you had to watch for the first lab. And I talked about the whole idea of the elements, why we call them the elements, is from the solid, liquid, gas was air, earth, and water were considered the building blocks of everything. And there's a video that goes along with it that I made today. And then there's something fun you get to do in your kitchen over the weekend or on the weekend, but that will be there tomorrow, if not tonight, probably in the morning. All right. So gas laws, there is a pre-lecture video. And so is a question Shaylee asked me in the last class. She said, should I leave? I didn't watch the pre-lecture. No, you should always stay, because I have noticed, Shaylee, I thought about your question quite a bit, and I do not think I'm like the greatest lecturer in the world, but something magical happens when you are present here when I'm teaching, and I don't know what it is. I've had people talk to me about it, and I've noticed this, that watching in the video is a wonderful thing, but actually being there, even if you only pick up a little bit, you're picking up more than just the words and everything there. But do go and watch that video if you have a chance, and I'll reference it. It's me doing demos. So usually as I'm doing this, I do the demos as we go through each of these laws. A gas, the word gas again comes from chaos, and something I talk about actually in both videos, the one that goes with this, the new lab this week also, is gases are about chaos. They are moving. So they are about movement. And that movement gives them weak intermolecular forces. So even something that had a strong intermolecular force, if you get it to a high enough temperature, those wiggles that happen as we move temperature higher, those wiggles will make it come apart. All right, this is the key, and I talk about this in the video. So if you were able to watch the video, you've at least heard this, and then the second time's better. And if you didn't watch it, going and watching it after might help to click some of this. But this is the key, that these variables, we are going to be doing algebra, which is awesome. I have a theory of why some of you don't like algebra, but attitude is everything. So just say, you know what, I love algebra. These pictures here actually kind of show you. So a gas is all about it's moving around, and there's lots of space. That's another thing about a gas. There is lots of space between the particles. I should write that in a different color. Let's write pre-lecture in a different color. So lots of space between. And that's what pictures are actually worth so much more. And so you can see, and they're showing that they're moving around. The liquid and the solid have IMFs. And the big key with liquids is they flow. They're fluid. We can pour them. Solids have the regular pattern. Sorry, I didn't give myself enough space. And gases says that they're disorder. So the word chaos, actually the word gas is the word chaos. All right, these variables. The P is pressure. So P is for pressure, V is for volume, T is for temperature, and the N is for moles. So if you watch the video, you probably already wrote all this down. So it is a lowercase n. The others are all capital. The units are important. So pressure, actually before units, pressure in one word. Here we go. I'll know who watched the video. What's the one word? What do you, when you see pressure?
Collision. Collision.
That was good. We should see how many people can answer. That was great. It is collisions. These guys are colliding, and this picture is actually really awesome. You can see they keep bumping into each other, and then they are considered, I can't remember, it's Galileo, that if you have truly frictionless and no intermolecular forces, they will collide and they will just bounce off of each other without losing any of their energy and stuff. Volume is what volume is. It's the space that they occupy or take up. So it's this whole box here. Everything's boxes now, right? All right. So here we go. So I see why Tiffany's got her screen on. She's like, I didn't get a point yet. I was like, Tiffany, you already have a point. But so go for it, Tiffany. What is temperature?
Giggles and jiggles.
Giggles and jiggles. Yeah, and the thing's flashing because
Brittany's answering with me.
I know,
too.
Brittany's like all capitals saying, no, I already have it ready to go. Giggles and jiggles and wiggles. And I really hope somebody's doing that 7-day challenge. I've had several people do it. I've done this now. Well, I've done it since the spring. And I think this is one of the greatest blessings of COVID is the lab, this gas lab that I had to create. And so I hope you have fun with it. And there is a reason we're doing it now and you have a test Monday, because if you do one of the 7-day challenges, it will probably make a difference on your test. I had somebody and absolutely did, it was her highest test, and she did the giggles and wiggles. Something happened, and so she was off by a couple days, and so she had to be doing it. And so she was in the heart of the giggles and wiggles while she was doing the midterm day. And so she actually said it was the lowest stress she'd ever had. And then the moles is just the number of particles, which is atoms or molecules. And this is important because you're going to see on a lot of these, I keep asking, does your answer make sense? Because that's really a key, and that's one of the wonderful things about gas laws. I see students do really well with gas laws. The order that I did things since the last midterm building up to our next one was from the hardest stuff, which was the naming, and then the IMFs and Lewis structures, and then gas laws. Yes, it is math, but it's all, as long as you can identify the variables, which I'll go through the way to do the math, and it ends up working beautifully. The units are going to be important also, and so I want to walk through that again because that allows us to identify the variables. So pressure is either going to be millimeters of mercury, torr, or ATM. Now, I talked about this in the video. These numbers, so 760 millimeters, 760 torr, they're the same unit. Torr was in honor of Torricelli, who is not on this page. This is considered standard pressure. So STP is standard pressure. So that's 760 millimeters mercury, or the 1 ATM. So ATMs are always going to be numbers that are small, like around 1. Millimeters of mercury, torr, are going to be very large numbers. So kind of keep that in mind. Space occupied, this can be liters, milliliters, cubic centimeters, any of those things. We've talked about volume since the very first day. Temperature, all right, here we go. Oh, I'm gonna give Brittany this one if she can do it. There is only one unit that you can use for temperature. She's not answering. So somebody else, anybody
Kelvin.
know? Who just yelled that?
Kelvin.
Okay. She typed it. Yeah.
Shaylee.
She did type it.
Did she get it? Sorry, you gotta laugh. I enjoy the enthusiasm. I miss you guys all tomorrow because it's early in the morning and everybody's like still sleeping. But I have like 3 people who answer me and the rest just turn their screens off. Yeah, so this is actually probably the most missed thing. And you'll all get it on the homework because we go over it, but Kelvin is the only thing that works here. So capital K. And that is because he took into effect the idea of giggles and jiggles, and the moles are moles. All right, STP. So, so somebody else can tell me. So STP is standard temperature and pressure. So 760 millimeters mercury, 1 ATM is our standard pressure. Anybody get what standard temperature was?
0 degrees Celsius equals 273 Kelvin.
It sounded like Shaylee. Was that Shaylee?
Yes.
All right. Shaylee, you and me are
Finally.
going to have a talk one of these days about crystals.
Oh, by the way, I got a malachite crystal this weekend. Thank you very much.
Where?
I went to a few shops with my fiance over the weekend. In like various parts of Portland.
Okay. We'll have to have a talk later.
Oralhurst area.
Oh, okay. So 0 Celsius is 273, and that actually, we'll see that a lot on this worksheet, same with this, but these are standard temperature. Now, when we get to temperature questions, you're gonna see it's always given in Celsius. We have to change that to Kelvin. All right, Boyle studied pressure and volume, and what he found is as you increase the pressure, actually, the better way of doing it, the volume goes down. So as you give something less space, so let's say you live in this huge castle and you can't afford it anymore, and so your family moves into a 1-room apartment. Your family, like Brittany's family of 6, moves into a 1-room apartment, not 1 bedroom, 1 room, and they are going to be colliding into each other. So when you have less space, you're going to have more collisions. It's usually easier to talk about as the volume is the cause of the pressure. It doesn't really matter the cause and effect thing, if that's real or not, but this is the idea. These are opposite One always goes up, the other one goes down. So this is how you want to solve the problems. To solve problems, look at this, we have space over here. Or I do, you guys might not. You want to make, first you want to make a list of the info. So let's go through that. We have here 2.5 liters. So I'm going to write 2.5 liters. That is a volume. So when you make the list of the info, you're making it with the variables, meaning P, V, N, or T. So that's our alphabet for this week, just 4 letters of the alphabet. And it tells you blah, 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 it's 5 ATMs. So 5.0 ATMs, and ATMs is pressure. So these two go together. I'm going to call them, just give them a 1. Because they're the first ones who went together. All right, now it wants to know what is the volume. So V2 is my question. And now it gives you a new pressure. I actually set a pressure, but 745 torr is my new pressure. This is the key, this step. So again, I recommend colors, underlining, and make this list. The second step is state your formula. Now, there's a whole bunch of formulas. I kind of wrote them all out on the board, and then I said we're going to condense it all into one. And on our notes, it's there. And we'll talk about this. Somebody remind me on Wednesday. This exam, there is a lot of information that we want to have organized on one page, so that you're not like rifling through papers and searching and doing all this stuff. And so in the past, they probably had an advantage because they didn't have all their notes and stuff to go through. So we're going to make sure we have the pieces that we want. All right,
Can I ask a question? In the video you had done on the pre-lecture, you had said opposite for Boyle's law. You said the pressure goes down and the volume goes up.
They always go opposite. So if one goes up, the other goes down. It doesn't matter.
Okay.
Yeah, I realized that as I started making my arrows, Tatum.
Okay, I just was like, wait a second.
No, and actually, if you go back and watch my eyes are going, oh, I'm going, and I'm like, but this is actually good, and your question is excellent because they always go opposite. So if you have more if you have less space, you'll have more collisions. And you're right, I talked about if you give it more space and we're not adding any more gas into it, then you're going to have fewer collisions. So like in class, it used to be really great because we had one class on Monday night and it was a big spacious lecture room. And then on Wednesday night, we went into a small room and you kind of collided. You didn't get to spread out into 3 seats. It's kind of like airplanes now. Everybody gets 3 seats. Whereas in the old days, it was like this whole thing of running into each other. But yeah, thank you for that. And I'm sure that's going to happen with some of the other ones. All right. Right now, the formula we're going to use, actually, this is going to be one of the formulas. Really, there's just 3 formulas that you want to write down. And I think on somewhere I wrote them down, that this has 2 different pressures, 2 different volumes. It just also had the T involved. So we just ignore the temperatures. We just leave them off. So the formula we want to use is P1 V1 equals P2 V2. So when you state the formula, you want to state it with the variables. And that's all we have are P's and V's. So we just leave the T off. All right, and then your third step is, I always say plug in, plug and chug. So you plug in and calculate. So I was told by the math department for many years that I did this wrong. So they made me retrain how I always did algebra, that they told me you have to rearrange first before you can plug in. I honestly don't care. I want you to state what it is. And if you learned algebra like I learned algebra, where you plugged in and then you rearranged, I'm perfectly fine with that. But there was a trick I had a student showed me, like I could do it, but it was something she had taught kindergarten. And she said, you actually learned this in kindergarten and we all forget it, is you circle the variable you're looking for. So we're looking for V2. That has to be isolated and end up by itself. And that is a key to algebra that a lot of people missed. I have a theory why some of you don't like algebra, and it is because it is introduced during middle school when puberty also happens. And so when you're going through puberty, you don't really care about algebra. Some of us, puberty was delayed, and so we were able to do the algebra without being distracted by all the hormones and things that were going on around us. But so that volume has to be isolated, which means if you were multiplying by the P2, you do the opposite. You divide both sides by the P2. So I'm going to cross out my P2, and there we have it. The V2 is isolated. Now here's the key. We have to plug in. And so I will have students, and they will make their list perfect. They will rearrange beautifully, and then they plug in like all haphazardly. And it's usually the students who are really good at math. And it is because they get a little cocky with this. And it would be a real bummer to blow the gas law page if you're in calculus because you got overconfident with your math skills. I had this lecture with my son because he like aced his first chemistry test in his other class, in his the class he's in, and then he didn't do any homework for a week, and so it was due like in 6 hours and stayed up all night. And I said, yeah, you know, just because you did really well. Anyway, so P1, it's right there, 5.0 ATMs. By the way, units, we talked about this before in the first part of the term. Is not the number, it's the number with the unit that is important. All right, you can check off as you use something because you should only use it once. And then our V1 is 2.5 liters. So if you want, you can check it off. You can even put a light line through if you have a pencil. And then we're going to go over P2, which is, oh, we have a problem here. So I'm going to write it in, and then here we go. Somebody tell me what my problem is going to be.
Your units for pressure are 2 different units.
Yeah. So that over here in the list, you may or may not have noticed it. So by the way, the abbreviation for torr is a little t. So you can write it out like I did here, or you can write it like that. I would recommend changing your torr to ATM because we're going to be doing that actually on the next page anyway. But you could change either one. But if you notice over here, your pressures are different units. There's probably 1 or 2 of you who can do it here within the problem, but that would confuse most of you. So I recommend you do it over here within your list. Get your units to line up. And it's right here. This is the conversion. 760 millimeters mercury is 1 ATM. But I'm going to want, remember millimeters mercury is a torr. 760 torr is 1 ATM. So back to the factor label, we would want the torr on the bottom so it cancels here. And you have to punch it in. If you notice, this was 3 sig figs, so we'll change this to 3 sig figs, so 0.980 ATMs. This is why you're going to show your units, because that way you notice, oops, wait a minute, I forgot to change my units back here. So I have found that this, when you, within your list, kind of take a check and say, okay, and now you just punch it in. And I limited myself to 2 sig figs in my answer because my V1 and P1 both had 2 sig figs. So sig figs, if you remember, it's just, since we're going to be multiplying and dividing, it's just the least number of sig figs. I do want you to show this step. So to get full credit, it is going to be, your test is going to be like the last one format. It is going to be show your work. And yeah. All right. And now we're going to answer if it makes sense. So Philip, you weren't here on Wednesday. You might not remember in the video. If you have a bonus point already, you don't get a second one in the class today. I just ask that you like count to 5 or 10 to give somebody else a chance to answer. So I'm going to see if somebody can tell me. And remember, you're going to turn your screen on so I can see who I'm talking to. We can all see who it is. So why does the answer make sense? Other than your teacher has used this for 20 years, knows her answers should be right by now. You're going back up to this up here. So if we look, let me answer this one, and then maybe on the next problem somebody can get it. If you look, our pressure was 5 ATMs. 5 ATMs is a huge pressure. This is like at the bottom of the deepest place in the ocean would be 5 ATMs. That's 5 times the pressure right now. You guys would collapse like that can did. So we decrease the pressure, which means there are fewer collisions. There is no change in anything else, right? Everything else was constant. So only way there can be fewer collisions is we must have more space. If they have more space, they're not going to run into each other. That's what I'm looking for on these questions. Does your answer make sense? And so kind of back to what Tatum, you had commented, this was how I explained it for something I did in class. Might have been my demo with the marshmallows. Yeah, it was for 6-month-old marshmallows because 6 months ago I didn't want to go into lab. It's kind of spooky because nobody was around and I would have had liquid nitrogen and everything. All right, so Charles' law is the connection between volume and temperature. So let's go ahead and just do our problem. And right, there's our pieces. So let's make our list. 0.50 liters is a volume. And we're at 20 degrees. Now, I know these two go together because of that word at. It's those, what are those called, prepositions? So I'm going to call them V1 and T1. And then it wants to know what's the volume. So my V2 is my question mark. And we're at a new temperature of 37 degrees Celsius. So again, rather than writing all those individual laws I wrote in the pre-video, I condensed it all into one law, which is here. We're going to use this. But there's no mention of pressure. So I'm going to leave the pressures off. I just mentioned volume and temperature. So we're going to write it as a ratio. V1 over T1 equals V2 over T2. So those are my pieces. Now, I'm solving for V2. Again, if you're somebody who's, I need to see your list, I need to see the formula you're using. If you want to plug in and then rearrange, great. If you've struggled with the algebra, I found this really works, is rearranging the variables. Circle the one you want. You don't move that. It stays put. That's what the circle means. So we're going to move the T2, and it's on the bottom. So since we were dividing, now we multiply both sides. You do the same thing to both sides. And now the V2 is by itself. Now, before, I was going to say, I can see you all calculating. I can only see Tiffany. Before you calculate, before you plug in, there is a problem. What is the problem? Brittany wants to say, anybody? If you watched the video, if you listened to me earlier, it was the giggles. There's only one unit that works for temperature, and that is Kelvin. Whenever you see Celsius, you write it in your list, and then you immediately change it to Kelvin. You just add the 273. So 20 degrees is 293. You have your calculator, and this will be 310. I recommend you do what I did, that you actually write it first, and then you can cross it out and write your new number. This is where colors work beautifully. And then you plug in. Just go ahead, plug in and solve. I'll like hum a song. Tiffany gets to hug her son.
It's bedtime. He wants me to tuck him in, so I'm gonna in just 2 seconds.
You can do that. And sing him a song. All right, so T2, we're multiplying. That means it's on top with its unit. I like to put parentheses. You don't have to, but I just like to keep things in their own space. So use that, and then I'm multiplying it by V1. So you want to make sure you get the right things on top, the right things on the bottom, and then we're dividing by the T1, which is the 293K. So something else you can think about, because I want you all to get this perfect, because gas laws ends up being, for a lot of people, they're saving grace, because this is, you cannot have a temperature times the temperature, so they have to always be on different layers. Same up here, you can't have a pressure times a pressure. So when you're doing the math, punching at your calculator, they have to be on different layers, and there's my answer. And somebody's going to explain to me why it makes sense. Maybe, maybe not. Well, we made a change in our temperature.
Yeah.
I increased. Somebody going to say?
I was just going to
Increase.
repeat the law because the temperature went up. So
Temperature means you have more jiggles, more kinetic energy. If you want to say kinetic energy, you can, but jiggles will help keep you smiling and happy. So as you increase the temperature, you have more jiggles. The pressure didn't change, so there's same number of collisions. So I'll put that like as a different color. So collisions are constant. Because normally you would think if you have more jiggles, you're going to start running into things. So same number of collisions, collisions are same. That's the word I'm looking for. So the only way you can be jiggling, I mean, these things are really moving. They're jiggling and chaotic. Is you have to give them more space. So the volume has to increase. So there's more space. When I say at the molecular level, you can restate just that temperature goes up, volume goes up. But I do want you to, with temperature, you would tell me more jiggles. So there's taking up more space for the same collisions. Questions with this page. And this is the idea. As long as you take that moment, and the people who clearly write out what they're doing end up solving these much faster and get them right, and then they can move on. The people who try to do it, I don't know what way. Yeah. All right, let's move to the next page. And this is Gay-Lussac's law. This is when I got the egg to go in the flask. That was only took like a half hour. All right, so let's underline our pieces. 4 liters, that's a volume. Just call it V1. And we're at STP. So STP means we have a temperature and a pressure. So 1 ATM. And we can say 0 Celsius or just change it right away to 273K because we're not going to use the Celsius anyway. So that's what STP means, is those 2 numbers. So that is something to be careful about, because we usually want to see the number. When you see the number in the problem, like down here, you know, hey, I'm going to use that. Yeah, but there it's just these letters. All right, and so now it asks, what's our new pressure if we're at 45 degrees Celsius? So you're like, oh, I got this. I know I have to change the 45 to Kelvin. Now, somebody will say, but what about the volume? It doesn't mention any change in volume, so we can ignore it. Nothing happened to the volume. All right, so here's our law that we're just going to write down on the paper. There's no change in volume, so we ignore the volume. So we write it how it is. P1 over T1 equals P2 over T2. Just leave the volume out. So rather than writing Boyle's law and Charles' law and Gay-Lussac's law, you can just look at this and leave out the variable that didn't change. All right. I'm going to count to 20 backwards. I can do the Zen thing and I'll count to 10, and every time my mind gets distracted, I have to start over. Probably will never make it to 10. Class will never end. Anyway, if you're doing the meditation, try that one. Count to 10. Count your breaths. You get to 10, you're done. But anytime your mind starts deviating, you have to start over. I made it to 3 once. It was a miracle. But it was one of the most amazing meditations. I think I was like 24. It was one of the first times I'd really meditated. I was in a class. Everybody else was saying they got to 5 or 6. I'm pretty sure they were lying. I was the only one humble enough to say I made it to 3 one time. All right, so circle the piece you're looking for, P2. So I'm going to multiply by the T2. Now, somebody will say, which means it's now on top. So if it's on the bottom here, you can do like the cross multiplying is another way to think about it, that the T2 ends up on top. And then just be careful to plug in correctly. So 45 plus 273 is 318. It has to be in Kelvin. It only works in Kelvin. So 318 Kelvin. You want the T2 on top. And then we multiply it by the P1, which is 1 ATM. You don't have to put the 1 on your calculator. And then we go over 273. Don't use the same number twice. Kelvins will cancel and we'll get the 1.16. All right, I forgot to ask, does it make sense? But I will ask you, does it make sense? Of course it does. My question is, why does it make sense? Temperature increased. So an increase in temperature means an increase in jiggles or giggles or wiggles or kinetic energy. So pressure went from 1. Huh?
If you put it in the calculator, like where you multiply it and then put the parentheses and do the division in the parentheses, does it matter? Because I still got the same answer.
No, if you're getting the same answer every time, you're fine. I'm not looking at, yeah, so on 3 sig figs. This is what I mean, and we're in the same space. So it's something I mentioned. Sometimes I comment that, I didn't on this one, but that the volume remained constant. The moles remain constant. You're supposed to say that with gas laws, and sometimes I do, and sometimes I don't. It's not a big deal. But again, this is what I'm looking for with doesn't make sense. All right, let's keep moving. So here we have 0.200 grams, 750 mils. I want to know how many atoms, and we're in this volume. So we make our list. So 0.200 grams, what? That's not a pressure. It's not a volume. It's not a temperature. And it's also not N, but this is Avogadro's law and says we're going to talk about N. So in your little list, you have grams. You need to change your grams to moles. And we're going to do it over here in our little list. And that is one of the things you need for your midterm. And you should have is your handy dandy periodic table. How do we change grams to moles? Is this what element are we doing with helium? Yeah. Remember helium? Right there, that number? The 4.003, we can go with 3 sig figs. That 1 mole is that many grams. So this is easy. We're going to get 0.500 moles. Okay, if you want to use, yeah, I'm just going 3 sig figs from the periodic table. So do this in your list before we plug in. All right, and that told us so that's N1. And so V1 is the 750 milliliters. And N2 is my question mark, but we're going to want to get to atoms. I'm just making a note to myself. And we have a new volume. So
I have a question.
Go ahead.
For moles, I got 0.05. But you
Yeah, yeah, it's 0.05. Because that's 0.2, not 2. All right. Thank you, Philip. Yeah, so that should be 0. You guys read my. I mentioned this in the video that the full law, and we can write it here, is the N's are at the level with the T's, so they would be down here. And so we're dealing with N's and V's. So this shows up on the next page, but how I just wrote this, we leave out the pressure and temperature. Now, before we plug in, I had this specifically on the next page, but it shows up here. The variable you're solving for has to be on top, has to be in the numerator. And it is actually a law in math. I call it the Yogic Law. And that is the law of inversion, that you can actually flip everything as long as you flip both sides, so your N's are on top and your V's are on the bottom. So whatever you're solving for needs to be on top, which is my N2. So the point of this question is to emphasize that the N is moles. And if you remember, we can change our moles to grams and our grams to moles. That's using the periodic table, and we can also change it to atoms or molecules. So if the question is talking about a number of atoms or asking for atoms, in gas laws, you solve for moles and then you do an extra step. Same with grams. So in this case, between grams and moles, we use the periodic table. You guys remember doing that? That was on the first test, and it's on the second test, and it will be on the third test, because it's one of the big points of this term. And this is Avogadro's number, which we're going to use in a minute. So you can write it and then flip over, and then we will plug our numbers in, rearranging. So if you want, you can cross multiply. So the V2 would move to the top here. We'll cross it out. And now we plug in. So 0, oops, I'm putting my moles in first. Kind of back to not quite the question Tiffany asked. It doesn't matter which one you write down first because you're multiplying them. There is going to be an issue before I move on. I was thinking that's what Philip was going to say, but it was my poor math. What's going to be the problem with my list? My units. What?
Someone else is going to answer.
Yeah. Philip's like counting to 10 every time.
This is Christy. You need to change your liters to milliliters.
Yes. So our volumes were different units. I was thinking that's what Philip was going to point out because I was waiting for somebody to point it out. So we do need to change them. It doesn't matter which one you change as long as they're the same. I'm going to go to liters for a reason that will become apparent on the next page. So either dividing by 1,000 or 1 milliliter is 10 to negative 3 liters. All right, so this one I can do in my head correctly, 0.750 liters. So it comes out as a nice little line over on the side. All right, so we have my moles. This is, I want V2 on top, so just be careful, 2.00 liters. And then that number, the 0.750 liters on the bottom. And again, as you do this, you can cross out your units once you plug in. So if you forgot to change them, you would catch it there. And then that's going to give a certain number of moles. All right, and hopefully you would then say, well, whenever you work with moles, take a deep breath and say it's moles. Is that what you wanted? Because usually we don't ask for moles. Usually we ask for grams or atoms. So, anybody remember it?
6.022 times 10 to the 23rd.
Yeah, if you want, you can do it. And that's atoms. So we're going to be multiplying by Avogadro's number. And we should make sure I got the right answer because that is actually a new question. Oh, I got it right. Good. But I forgot my unit. Shame on me. All right. All right. This one, does your answer make sense? To compare, we have to look at the moles, not at the actual final answer. And so we increase the moles, the number of atoms. It's hard to see that we increase the atoms from looking at the grams. And we're looking at volume, so it takes up more space. So we have an increased volume. And you can write, yeah. All right, there's our combined gas law. So this is actually an important question. You're going to use it. It's what we just did, all these problems. It's the next two problems. When you have two of the same variable, meaning two volumes, two temperatures within the problem, you're given two pieces of information of the same variable. Because we're going to have two other formulas we're going to work with on the next page. So if you look, all of our lists that we made, like here I had two volumes given. Up here I had two temperatures given, and on the previous page. So go ahead for number 5, make your list. And Christy answered me there. Okay, so this, I'm like, right, you guys are like my favorite class because you actually participate. My class on Thursday, I decided, oh, I'm going to do this with them. They're going to participate. No, I did not give out a single bonus. Nobody would answer me. And yeah, it was, I'm determined tomorrow is going to be different though. They're all going to answer me. And there was a question Katie asked me, Katie who's dressed like an owl, in the email, because when I sent out the other email, you were supposed to reply to that first email, and if everybody answers me, then we get double points. We didn't even come close. We didn't even get halfway. But that holds true for this. If everybody answers me tonight in a bonus, we all get double points. But I gotta have a dream. It's never happened, but got a dream. All right, so 8.65 liters. So I'm just gonna call that V1 because it's the first one I came to. And this is all in the same sentence. So 1.15 ATMs, that's a pressure. And 35 degrees Celsius, that's my temperature. So these go together. They were all in that same sentence. I can't emphasize this enough. This is the key. you have to identify your variables right. And it's the unit that tells you what piece it goes with. All right, so it wants a new volume. So V2 is my question mark. You can use different colors for the different sets, like the ones can be pink and the blues can be 2s. And we're at 655 is my P2.
308 Kelvin.
And yeah, we'll get there in a moment. Thank you. All right, so there's my list. So make your list. And what Tiffany was doing was she actually anticipated my question, which is we know what formula we're going to use, but before we're ready to plug in, you can write down your formula. Just give yourself space because we have to fix our list. Because there's a couple things wrong with our list. And so what she told is this is going to be 308 Kelvin. You have to be in Kelvin. So anybody want to tell me why it has to be Kelvin? If you watched my video, you know. And this one is, nobody's going to answer me now. 298 Kelvin. All right, and the other piece on the list is, if you look at the pressures, they have different units. They have to have the same. Sometimes you don't catch that until you plug in, especially like in a test, because you're like so excited, because you're like, I can do this, I've got it. It's not nerves, it's that you're so excited. See, if you flip your perception and say, maybe it's not that I have test anxiety, maybe I have test like excitability. I'm so excited to show my teacher that I know all this stuff. I'm just so excited that it will change it. So you just have to change your mindset. I'm going to change to ATMs. If they're both in millimeters of mercury, you could leave it like that, but let's go ahead and change to ATMs. You could have changed them both to millimeters of mercury, that's fine. So 760 millimeters of mercury is 1 ATM, and I'm going to find my number here and then go ahead and plug in and you should get my answer. Yeah. So at least rearrange and then plug in. All right, ATM 0.862. Yeah. Again, circle the piece you need. And then you can cross multiply. So the P2 is now going to go down. And the T2 is going to go to the upper level. So this is what we're going to plug into. You can use all the same color. I don't know why I switched pens. Again, you can't have the T's end up on the same level. So that's something to ponder. All right, let's go ahead and plug in. This is the one when you have several variables, 3 variables that you're working with, to just be careful. We want T2 first, so 298 Kelvin. And then we want the P1, 1.15 ATM. You can cross off as you use them, then the 8.65. And then on the bottom, so I'll have students, they make a beautiful list, they rearrange beautifully, and then they just throw things in there. There's a reason. This says P2, this says P2. This is the one we just recalculated. Showing the units, so my ATMs will cancel, and now I need my T1, 308 Kelvin. All right, so we're gonna end up with liters. All right, we'll go through why does it make sense. If somebody has a question, just ask. But this one's a little bit harder because there's two pieces that changed. And I'm taking a gamble here that, so I decreased the pressure from here to here, which a decrease in pressure should increase the volume, right? Those are the ones that go opposite. And we'll talk about this a little bit, about a half hour, how you can keep that from just looking at the formula, knowing that. And then temperature, though, also dropped, which should decrease the volume. So this is a tough one because there's two variables and they should have had an opposite effect on the volume. It's the variable that changed more, and that's hard for most students to see. The change in temperature is actually not a huge change once we get to Kelvin. The change in pressure was the more dominant one. This is why I usually avoid asking this question when there's three variables. I usually ask it when there's two. So let's just move on. If somebody wants to talk to me about it, we can during an office hour. But this, if we had a highlighter, this formula is actually one of the key ones. So this is going to be the inversion one. So make your list, and this is going to be the formula we need. So play with it and see what you can do with it. So at least make your list. I'll give you a moment.
Can you go back for a moment, please? I just didn't quite get the last part, just for a second.
The explanation?
Yes, I just wasn't done writing it down. Just that part. Thank you.
All right, I am just looking at the time. I'm going to kind of move fast here. The answer's there. I just want to point out a couple things with this one. You would list your variables, show your formula. The question wants us to find the temperature. Now, the thing that's interesting on this one is I asked the question at the very beginning. And so my question, I just said at the beginning, I'm calling that T1. And so this is my V1 and my P1. It doesn't really matter what set of variables are your ones and twos. It does matter that you group them together correctly. So my question is going to be the T1, and then you would have your T2, V2, and P2 would be the other ones. We're going to want this formula. Again, I'm going to go through this one pretty fast. I'm not going to do the whole thing. What I wanted to point out with this one is, again, if you're solving for temperature, I left off the moles, the N, because there's no change in moles in the question. You would make your second set of data, T2, V2, P2, blah, 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 is since we're solving for T1, this is one of the two mistakes that are made all the time by half of the students. It's not going to work because it's in the denominator. It is actually my most math challenge students who get this correct because they listen to me and they take the time to solve it. And it's all the wizards who are careless with this. You cannot solve with the T on the bottom. You have to flip this whole thing. Both sides. And then we're solving for T1 this time. So these guys would come up here. And then you would plug in. And when you solve, you're going to get T is going to be in Kelvin. Sorry. My question is, how do you get back to Celsius when you get Kelvin? So you end up with, yeah, so if we added to get there, we would then, so this is, I guess, what the answer comes out. You would subtract the 273. and you would get to my answer in Celsius. So moving to Kelvin, we add, moving back to Celsius, we subtract the 273. All right, I want to go through, we have a couple more problems we got to do. There is, and I mentioned this in the video, it all moves that we end up with the ideal gas law, which is PV equals nRT. R is a constant. It is called the gas law constant. We're going to use this. There are different constants, and what makes them different is the units. And you use it in question 7, 8, and 9 here. And this is how you're going to know you're going to use it. So let's make our list. It's asking what's the volume? And it gives us, okay, 0.200 grams. So that's going to be my moles. I have to change my grams to moles. And we know how to do that. So there's a couple of tricks that happen in this question. And so I want to point that out. And it has to do with chlorine. And I just realized I never taught you this because the order that we do this in is different. And this gets driven home after the midterm, but we're going to do it now. Chlorine is what's known as a diatomic. And you have all worked with diatomics since preschool. You probably know oxygen. Oh, the moon is rising. I can see it out my window. It's pretty awesome. Is O2. We always write it as O2 when it's by itself. And that is because it's so freaking unstable that there's always two of them together until it reacts. Nitrogen is written as N2 and all the halogens. So N2, O2, and then the halogens. When we're talking about them just as them. In a compound, you go with whatever I give you. But these guys are what are known as diatomics. They make a 7 because there's 7 of them. It's not that your teacher can't count because that is only 6, but it means when they are a gas, as a gas, these are the gases on the periodic table. You know, we're in our classroom. The periodic table is color-coded based on their states of matter. The gases are diatomics, and hydrogen is the other one. That's the missing one. The exception is the noble gases, because the noble gases, remember, are perfect. There's no reason for them to combine with anything, including themselves. But if you see just chlorine by itself, there's always 2 of them. So when we do this, we have to add up 2 of them, which gives us either 70.9 or 71.0 because it is Cl2. Usually I give you a formula and stuff, but I think I did this on purpose to do that. So you would calculate your moles here. And then it tells us STP. So our temperature is 273. And our pressure is 1 atm. Now, I'm calling this P1 and T1 and V1 and N1, and there's no P2, there's no V2, there's no N2, there's no T2. There's only one of each variable. So when do you use it? When there's only one of each variable. So you make your list, and your list tells you which formula. So we're not going to do that one on the other page. We would write PV equals nRT. Now, this again, I'm scolding the little math wizards the most because it really perplexes me if they're trying to show off or what. But rather than taking the moment to write the formula, they decide they're going to rearrange it and just write it down, rearrange, because that's going to save them all of like 10 seconds. And they end up doing it wrong because they do it in their head, and sometimes it doesn't work well. So write down the formula, how it's going to be on the sheet, and then we want volume. That B has to be by itself, so we're going to divide by the P. So it's nRT over P. All right, I have to find this number. We'll actually go through solving this one. So on the next one, if you like already moved ahead, oxygen is O2 by itself. Okay. So apparently the moon came up and my calculator has decided not to work. Oh, there we go. So I want to plug this one in for a reason because of the R. When you write R, we're going to use this R. I recommend that you show the units. Write them really small. It is ATMs times liters over mole K. That slash means mole K. If you write out all your units, and the pressure is 1 ATM, a lot of students, it is really helpful for them to see how all their units are going to cancel. So the ATMs cancel, the mole cancels, the K cancels, and you're left with liters. Constants in chemistry and physics usually have really funky units, and their units are to make everything cancel out. What it means when you use R, when you use PV equals nRT, you must be in these units. So you have to have ATMs, you have to have liters, you have to be in moles, and you have to be in Kelvin. That's if you use R. On the previous pages, I didn't always change my units as long as the units canceled out because it was all a ratio and we weren't using R yet. So like in this problem up here, probably I would have just kept it in milliliters. If you're ever unsure if you have to be in ATM or liters, just always go to it. Better safe than sorry. Kelvin, you have to be in because Kelvin is the only scale in temperature that took into effect the idea of movement. Celsius did not. He did his based on the liquid state, and so that's why it doesn't work. All right, I want to do this problem. Number 8, you can do on your own. Number 9, because it brings in something which is where we're going next week after your midterm. And that is the essence of chemistry. So the first midterm was about the elements. Subatomic particles, making up the elements. This midterm is about compounds. So naming compounds, how compounds form, drawing out the pictures of them, looking at their states of matter of the compounds. Our next midterm is about chemical reactions, which is transformation, right? And that's what's going on. And so this arrow separates. We saw this when we did radioactivity, but this is just a little bit different. The S, and G are our states of matter. And so this is, I think, a bonus on your worksheet, that bonus question where I forgot some of the information. Gas laws for this equation are only going to work for nitrogen. Gas laws do not work for solids and liquids because they are not moving around chaotically. They have strong intermolecular forces. They are not behaving in a way that will allow us to have a pressure. They have a volume, they have moles, but the pressure, they're not going to be colliding. They're just flowing or they're just sitting there. All right, so let's look at our information. We have 25 liters. We have 1,000 millimeters of mercury. We have 22 degrees Celsius. So I'm going to show you where all this is building to, and this is, you're going to be like, well, that wasn't hard. What's the big deal about that? And it's not. So let's label. We have a volume, we have a pressure, we have a temperature. We want to change them to these units up here. So, right, change your 760 millimeters mercury to your ATMs. Change this. We get 295 Kelvin. So we're going to do PV equals nRT. because we have a P, a V, and a T. We only have one of each. And what variable must we be solving for? Rather than worrying about all the words and all these things, say, okay, what do I have? And what can I do with that? We must be solving for N. Yeah, because we know P, we know V, we know T. R is a constant. There's no reason to ever solve for it. So we're solving for the N. All right. So divide by the RT. And I'll give you, go ahead, try it. All right. Again, in the interest of time, I want to show you something that for maybe one or two of you, it's something you could do if you want. So our pressure was what, 1.32 ATMs. Just keep it as 3 sig figs. 25 liters. And I don't recommend this for most of you, but this is why you don't want to ever see my notes. I never write R out. I just write R. And I just know that means that number. And so I just put it in. In fact, if you have one of those really fancy calculators, one or two of you did, it's actually already programmed in your calculator. And then the 295. The other thing I wanted, so I recommend for most of you that you write the number in there. You want to make sure you divide by both of these numbers. So like a double parentheses on your calculator, kind of back to the question Tiffany had asked me earlier about how she was putting it in. When there's two numbers in the denominator, you want to make sure you divide by both of those numbers. And, right. So I get a number here, and this is moles, because it's N. This is not my answer. So whenever you solve for moles, we want to go back and see what my next step is. So this was really my step 1, was my gas laws. So my step 2, and I'll give you a hint on the bonus, you actually have to do, it goes reverse the steps, but you'll see. The question wants us to find the mass of sodium azide. And when I was writing your notes up, I pondered about taking this question out, but I'm like, no, just because you guys are online doesn't mean we can't do it. I've always shown it this week, and it actually makes, it's a difficult question right now, but it makes future weeks easier because you'll have seen this. And again, on the worksheet, it's a bonus. You can be like, you know what? No, I'm not going there. I'll wait till we get there. This is the gas. This is 1.36 moles of nitrogen. And I know that because it's a gas. And gas laws only work for a gas. But the question wants me to find sodium azide, which is this. So another quick comment for you is sodium and nitrogen, what are we doing here? This is an N3 with a -1. That is what that is. It is called azide. You don't need to know this, but it is what is in every airbag that is in your car, in every car, because that you should be looking at going, that makes no sense at all. That's like an F student. This is so freaking unstable. It's why it's in your airbag. Just a little bit of a tweak, and this thing is going to become nitrogen gas. This happens in a femtosecond. It takes a nanosecond for your nerves to realize, uh-oh, something bad's about to happen. This has happened a million times faster. It already knew, and it became nitrogen gas, and gases take up all the space they can, and they blow up that airbag before your body has had a chance to move. And so the trick with this is our gas, this is our moles of nitrogen, is we're going to bring our moles of nitrogen down here. Now, I don't want the grams of nitrogen. I want the grams of sodium azide. And these little numbers here, which we're going to be talking about next week, this is what, after your midterm, those mean moles. So these little numbers, that's what chemists love, moles. These are moles. So we're going to do a mole to mole ratio. Remember doing those? And again, this is a bonus on your worksheet, which is the take home. You can come early or stay after on Wednesday and say, yeah, I want to walk through that. I want to try it. I've got the other gas laws. I want to see where we're moving to. And so I just put those numbers in. What's what they go with? There's 3 in front of the nitrogen, so that means 3 moles of nitrogen. And there's a 2 in front of the sodium azide, so that means 2 moles of sodium azide. And then I bring that down. I only bring 1 down. The 2 only shows up in that step, and I go to whatever the grams of sodium azide are on the periodic table. You guys know how to add that up. We can do it. Which is somewhere around 65, and we would punch it in, and we get my number up there. So this is a balanced chemical equation. And that's all those little numbers mean. We're going to learn how to get to those little numbers next week after the midterm, and then we'll do the math with them, unless I change my mind, but that's probably what we're going to do. All right. Got one more page. And this page is pretty fast. So, questions? I'm going to turn the page. You can always watch a video if you've missed something. This is the other formula I use and that I recommend you use. I used to teach this different. I have 25 years of experience, and this one really rocks, and it just has to do with what the variables stand for. You know what the P stands for. You know what the T stands for, pressure and temperature, and you know R. It's a constant. So the units are important because we're using R again. So that means my P is ATMs, my T is Kelvin. T is always Kelvin. So what does the M mean? This M is not the M we worked with before. So don't worry, don't think about that. It's an unfortunate thing. There's a lot of words in chemistry that start with an M. This M is molar mass. So here we go. Bonus question. What are the units of molar mass? What is molar mass? Is anybody still there?
Moles over liters?
No, that's molarity. That was the one I said that's not what this M is. There's a lot of M's in chemistry. Molar mass has to do with mass, and it is how many grams are in a mole. It's from the periodic table. So there's a couple different M variables. It is the context of this problem of gas laws. Molarity is when something is dissolved in water. These are gases. They're chaotically moving around. They're not going to be dissolved. The D stands for density. And the units of density are mass per volume. In this case, it is grams per liter, because gases take up a lot of space. When we did liquids and solids, it was grams per milliliter, because they're very compacted. They have strong intermolecular forces. This is grams per liter. Makes sense. So when do we use PM equals DRT? I don't know that you're going to find this formula online. One of my colleagues showed me this formula, and it really rocks. If the question point blank asks, what is the density? This one solves straight for density. Or, what is the molar mass? We just can plug in. So I'm not going to walk through these. This gives you, it's carbon tetrachloride. So it is, assuming that you learned something in the past couple weeks. So that would be a carbon and tetra. What would be the formula? Anybody?
4 chlorides.
Yeah, so we'd show it as CCl4. So using the periodic table, you can find the molar mass of that. I give you a pressure, I give you a temperature. As for density, you just do PM equals DRT. So this one, molar mass, PM equals DRT. So these two pieces together will find our density, mass divided by the volume. This, you have to put the ATMs. This, you need to put the Kelvin. And then you need to try it. You need to plug in. You need to try and solve it. All right, I'm going to go through the rest of these. This has a lot of dense information. If you need to leave, you can leave. It will probably take me about 10 minutes, maybe 15. Dalton's law of partial pressure. Does anybody remember who John Dalton was? He's got a statue in Manchester, England, to him sitting there. He's a dude who brought back atoms. Anyway, partial pressures is that pressures can be added. So we have nitrogen and we have hydrogen. And this is how it is written. The pressure of nitrogen plus the pressure of hydrogen equals the pressure total. So this is like a subscript. It's just a shorthand way of saying the pressure of each of these pieces. So you just add them. The nitrogen was 250 torr, and the hydrogen was 425 torr. And we add them and we get how much? 675 torr. So you can add pressures. You can add moles. You can't add anything else. Temperatures, you can't say, okay, this is at 200 and this is at 300, so we're now at 500. Temperatures don't work that way. Temperatures are about jiggles, and so when the gases combine, they just meet a mean giggling point. Same with volumes. When you mix them, the gases will expand to whatever space there is, and so it really depends on it, but pressures we can. All right, this is, we kind of already talked about it. These are some of the key points about gases, so you can compress them. Gases are 99.96% nothing. There's all this empty space. I have the question mark there because is it really nothing? There is more empty space inside the atom than there is between gases. So in this room, like the room you're in, or if we decide to fly to the moon, I can see the full moon out there, we would think, okay, outer space, there's nothing, there's so much emptiness. There's more emptiness inside of the atom, but in this like box here, or in the room you're in, there are nitrogen, oxygen, mostly nitrogen, oxygen, some CO2, some H2O vapor, maybe a noble gas or two. And they're moving around, and there is mostly emptiness, 99.96. In fact, if you had 99.96% in the class, you'd be thrilled, right? All right. Something really cool about outer space, there is so much empty space in outer space that hydrogen is never a diatomic, because same with oxygen, if it was out there, it's not out there, because it never comes anywhere near another hydrogen to be able to hook up and become a diatomic. It's pretty cool. However, again, every atom, there is more. It's 19 nines now, 99.999999999. All right, they are continually moving. We talked about that. The movement, diffusion and effusion, they're just two different fancy words. We're not going to worry about them. This one, though, is a key point. And we already talked about that IMFs are weak. That kinetic energy, the movement, is proportional to the temperature. We've actually already talked about that. But this is kinetic energy. There is a formula. You don't need to know the formula, but it helps me to explain this. This is like one of the few things you remember from physics if you ever get to take physics. That kinetic energy is equal to 1/2. This is the mass. And the v is a little v. This is velocity. And what it means is as the mass goes up, the velocity drops if the kinetic energy stays the same. So as things become more massive, they move slower. You guys already knew that. I call it the Thanksgiving principle. You go to Thanksgiving dinner, you eat a lot of food, you usually are not moving very fast after. In terms of gases, if we look at the noble gases, which noble gas is going to be moving the fastest if they're all at the same temperature? Because if you increase the temperature, you give them more giggles, changes the game. But if everything's at the same temperature, which of the noble gases is going to move the fastest?
Does the lightest one in mass move faster?
Yeah, so it would be helium. It's going to be the smallest one. Helium's going to be moving the fastest, and our chart doesn't have my chart doesn't have the OG, but as they get larger, they're moving slower. Again, this is assuming the temperature is constant. But really, these points here, we kind of already talked about them, that you can compress and expand them. They're all about motion, and that temperature is about kinetic energy or giggles. And this point is key. So I want to go through question 13. So I think it's the last question on your study set. It's probably the last 2 questions. Have you doing stuff like this? And so I'll go through it more with the study set, but this way you can at least try and approach it. So you have a cylinder and it has a piston that moves. So it's just saying you have like a cylinder and you can compress it. So you have something that can close it and open it. So we can increase and decrease the volume. And so it wants to know what's going to happen to the pressure if we do each of these things. So if we double the volume, which means I increased it, we have double the space. We increase the space. Temperature doesn't change, so we ignore it. If you have more space, pressure is all about the collisions, well, then you're going to have fewer collisions, which means you're going to be at half the pressure. If this one goes up by 2, this one's going to go down by 2. So the pressure is now at 1/2. It is always a proportional change. So, so now we're going to increase the temperature 3-fold. So triple the temperature, 3 times the temperature. And this time the volume is constant. So no change in volume. So if we have increased the giggles, 3 times the giggles, isn't that an awesome way to end the class? So if you have 3 times the amount of giggles, what's going to happen to the collisions? You guys have all been there where you just like are laughing so hard and you're with a group of friends and you just start really giggling. You're probably going to bump heads or something and then giggle even more and then bump heads even more. So you're going to increase the collisions again. Or this time we increase the collisions. So if you have more kinetic energy, everything's moving around 3 times. It's the Halloween principle. If you give the kids 3 times as much candy, they're going to go 3 times as crazy and they're just going to be running into walls and stuff. So we're going to get 3 times the pressure. So if temperature goes up, pressure goes up. So there is a trick. I want to leave you with this thought. And it goes back to PV equals nRT. Everything, all those other formulas come back to PV equals nRT. If you're ever in doubt what to do, you can solve everything with that. But again, the formula, this PM equals DRT, if it point blank says, what's the molar mass? What's the density? This thing rocks. And then this one, this is when we had 2 of a variable. So we just use that formula. PV equals nRT is if nothing else works. But it also helps us with this. And this is probably because my birthday was back in October, so I'm a Libra, so everything to me, I think of like a scale. This is my weak attempt at a scale drawing, but it has to stay balanced. So to stay balanced, you can draw a much more elaborate scale. I think Christy can be like my artist for the class. She draws beautiful pictures. All right. If I'll do it in blue. If nothing changes on this side of the scale, if I increase this, then this has to decrease because it has to stay balanced. So when they're on the same side of the scale, they always go opposite directions. So that would happen over here. R doesn't change. We can ignore R because it's a constant. So what if you're on the opposite side of the scale? Well, if the only thing changing is the pressure, then, and the volume doesn't change, like in this example, then the temperature, something on the other side, has to also go up. So when they're on opposite sides of the scale, opposite sides of the equal sign, they go in the same direction. If one goes up, the other goes up. If one goes down, the other goes down. If they're on the same side, they go opposite to keep the scale balanced. For if you don't like that, you don't have to use it. There's always, like about half the class goes, oh, I like that. And you'll know when you get, it's like the last question on the homework. They're like, that to me makes more sense. And about half of you were fine with the word explanations that, okay, I have more giggles, I'm going to have more collisions. Or I have more space, I'm going to have less collisions. All right, any questions before I stop recording? And again, there was that typo on the worksheet. Last question, if you decide to do the bonus. And there's 2 labs for this week. So make sure if you didn't look at the Got Gas, look at it today so you can start it. I'm going to stop recording.